Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, we're going to talk about percents greater than 100, mostly. And we'll talk about percents less than 100, but so the word percent, I love words because sometimes they make sense. So per, like if you said, like if you went to a garage sale and you saw something that looked like this, like $1 per $1 per DVD. Someone was getting rid of DVDs, so you might see a price tag like that. So that means per, and then cent is per hundredth, because a cent is 100th of a dollar, right? So, and that word cent is a Latin word, and just like centimeters, 100th of a meter. All right, century is a little different. That's 100 years, but yeah. So per hundredth, a lot of people do this where they like take the 100 and then they put the 1 there, and then they put the 2 zeros there, and it looks like a percent. Hey, look at that. Whatever. Okay, but you guys know percents. So in algebra, we can use a variable like what percent. Like you could say what percent, so what over 100. But I think it's easier if we just kind of keep it simple and leave our variable as just a normal p. And I'll show you some examples. So 20% of what number is 15? Okay, so in the past, we would have to basically think about this problem. We'd have to say, all right, I think you have to divide something, but you might have to multiply something, that word of, but you don't know what number you're finding a percent of. So then you have to like use your brain. You don't have to use your brain. Just translate this. How do you say 20% in math? 20 hundredths. You could do that. You could say 20 over 100, 20%. Or what's another way to convert a percent?
You could simplify it.
You could simplify it to 2/10 type of thing. But thank you. Yep, we're going to do a decimal because for me personally, since I have a calculator available, and even if I don't, I would probably rather work with decimals than I would with fractions. I mean, there's some people who like to work with fractions, and it depends on the problem, I guess. Sometimes fractions are easier, but most of the time, I'm going to choose a decimal. So we're translating this. So percents, when I say 20%, that is completely useless in a mathematical calculation. Percents are more of a concept, but so we have to convert this to something that's calculable. I think that's a word. I don't know if it is. Okay, so we either have to change it to a fraction or a decimal. So we're going to change it to a decimal. 20% is 0.2, right? So far we didn't really think. We just moved the decimal over 2 places. I guess you had to think about how many places to move the decimal, but so far it's not a whole lot of wear and tear on your brain so far. How do you say of in math? Times. So multiply, so that's a little dot there. How do you say what number in math? Yeah, WN, that's our variable. So you can choose whatever variable you want. I usually ignore the W, and I'm looking for I start with the letter of what I'm looking for.
Students, attention teachers and students, one quick announcement this morning. Normally each year we have an assembly to recognize the students who made honor roll. This year we are not able to have an assembly. So your teachers will be handing out your honor roll certificates in class this morning. Our honor roll is bronze, silver, and gold. Bronze honor roll is students who have earned a 3.5 to 3.74 GPA. Silver honor roll are students who have earned 3.75 to 3.9 GPA. Gold honor roll are students earning a 4.0 GPA. Those certificates will be handed to your first period teachers this morning, and they will hand those out to you. Congratulations to all our honor roll recipients.
I haven't gotten any certificates. Hope that doesn't mean that nobody is in the honor roll. And then is 15, that's pretty easy, equals 15. Did you guys have to think about this too much? No. 20, I mean, this was like the hardest part, I guess. 20%, 0.2 of, multiply, what number, that's your variable. Anything coming after what is usually your variable. Is equals to 15, stays the same. So now, how do you get n by itself? You have to get rid of this 0.2. What's that 0.2 doing? Multiplying, so now you divide. So I guess now you swipe up your translator app, and now you can start thinking about the algebra part. But algebra, you're still not thinking about, okay, do I have to multiply or divide to figure out this out? You don't have to do that anymore. You can use algebra to do your thinking for you. It's okay. Who do we got here?
A lot of people.
All right.
I saw your
Okay, I'm going to start with the silver. And this is recorded. Okay. So, Miss Perry got a 3.8 GPA, nice work. Mr. Branch, 3.8. Ms. Pryor, 4.0. And Ms. Bushman, 4.0. Nice work. All right. Second semester, here we go. So we're going to divide by 0.2, whatever you do to one side, do to the other. Remember, and really, if you want to look at your steps to the equations, everything's simplified. There's no variables on both sides. There's not even a constant on the variable side, a constant term. Remember, terms are being added. There's no constant being added. There's just that coefficient. So you're just doing step 4 in solving equations. So this is where your calculator would come in handy, but let's think about this. What's 15 divided by 2? Well, it's not even, so you have to cut something in half. What is it? 7.5. So if you divide by 0.2, you just move the decimal over one place. So this is 75. Okay, but use your calculator. There's no shame in that. And then go back to your problem and see if it makes sense. 20% of 75 is 15. Yeah, that makes sense. Okay. 20% is almost a fourth, or 20% is a fifth. A fifth of 75 is 15. That works. Boom. All right, next example. This time we are looking for our percent. So here's what example 2 says. What percent of 140 is 98? Okay, so this is a problem that you haven't really done a lot of, but that's why algebra is going to make this easy. So let's translate first. How do you say what percent? What variable would you want to use if you're looking for a percent?
P.
P is a great one. Okay, what percent is P? I mean, you could technically go P over 100, but I think that's going to complicate things. So what percent? And how do you say of? Times. And how do you say 40 is not 140 is 98? How do you say that? 140 equals 98. All right. We didn't have to think too. The only thing we had to think about was what letter to pick. I guess you have to remember what of means, but if you had to remember what is means, then maybe turn on your brain a little bit. But so that's it. So now we just solve equations. See, we're still not thinking about percentages. We're not thinking about, okay, do you have to multiply or divide or whatever? Now you're just moving to algebra, who does the thinking for you. So now we have to get P by itself. How do you get rid of that 140?
Divided.
Divide it. So what is that on your calculator?
0.7.
All right, so P equals 0.7. Now, here's the only catch. That P reminds me, oh yeah, I'm looking for a percent. So this should be a reminder. Now turn your brain back on. 0.7%, that doesn't make sense, right? Because 98 is more than half of 140, so 0.7% is less than 1%. So, oh yeah, I'm looking for a percent, so I need to change this to a percent. How do you change a decimal to a percent? Elkin?
Over to the right twice.
Twice. So we ran out of digits, so add a 0. So this is 70%. Okay? 3 steps. Step 1, translate into an algebraic equation. Step 2, solve that really easy algebraic equation. You're really just doing this one. Sometimes you're not even doing that. Sometimes you're just doing step 1 and then your n is by itself. Okay? And then step 3, if you end with a decimal and you're looking for a percent, make sure you move that decimal over. Okay? All right. So I'm going to skip a few here. So this is the title of this lesson is percents over 100. So we've already talked about this. This is just more of a refresher. So now it's really easy to get confused. So I'm going to skip to example 4. And here's what it says. What number? No. Skip to example 6. Example 6 says this. What percent of 90 is 306? Okay, so see if you guys can do that on your paper. Then you can use your calculator to finish the math on that. Okay, I'm going to join in. First thing I'm going to do is translate that. What percent P of multiply 90 is equals 306. So now I have to divide by 90. Okay, what happens when you divide by 90? What do you get?
.4.
So you get 3.4. So is that your answer? No, still, no matter how hard it is, move the decimal over 2 places because you might end up with 34. If this was 3060, then you would have ended up with 34. even though that's not a decimal, you still have to change it to a percent. Okay, because really every number is a decimal number. The decimal is just hidden on the end and on whole numbers and counting numbers, right? So you still move it over 2 places, boom, boom. So your answer is 340%, not 34%. You always move it 2 places, no more, no less. Okay, and that makes sense because 340% is more than the whole thing, right? It's actually more than 3 times the whole thing. So that makes sense. What percent of 90? So think about 90 kittens. Okay, what percent of that? What part of that 90 is 306? Whoa, wait a minute. 306 it's not a part of 90. It's way bigger than 90, right? It's all of 90 plus a bunch more 90s. Okay, so that's why there's a percentage over 100. So have you ever heard a coach say, I want you to give me 110% on the court? You have it? 110%. Well, and like, I don't know if I said this when I was a kid, but I was like, Coach, that is mathematically impossible. Okay, I can only give you 100%. That's not good enough. So, yeah, obviously you can't give 110%, but we do use percentages over 100 a lot. Okay, so for example, if we had too many people in this room, we are at 150% capacity. Well, 100% capacity is about 11. I think that's our limit, to have 11 people based on social distancing type of thing. So 150% would be 11 plus another 50%. So maybe like 17, in between 16 and 17, 16.5 people in here. So that's 150%. So we use percentages over 100 a lot, but it looks weird. It feels weird to have a percentage over 100. Okay, I'm going to do one more, and this is going to be for a free problem set. Okay, so if you can get this, not even if you can get it first, but if you can get it at all, you are going to get a free problem set. Okay? So, I'm going to erase this. Now remember, how do you calculate tax? Anyone know how to calculate tax?
That is something you probably should learn later.
Yeah, you probably should.
But I mean, I think it's better to learn it when it's like
Right, you can come back fourth period for our pre-algebra class, because we're talking about tax and pre-algebra.
Dang, you never taught me.
What? No, I did. You were just not paying attention, apparently.
Wow. Wait. What year was pre-algebra?
Last year.
Okay, I'm just saying middle school is not my time to shine.
Okay, so can anyone just explain to me, like, hey, mom or dad, what's tax? Why do we pay tax? Well, not why do we pay tax? That's a whole other discussion that we don't need to get into. But what is tax? How do you calculate tax?
It's like a percentage of money that you get, I think.
Money that you what?
Like,
like for when we pay our taxes, yes. But I'm talking about when you buy something at the store and you pay tax.
6% of what you paid, right?
Yeah, so, or it depends on the county you're in. 6% would be nice, actually. But you pay a percentage on top of what it says on the price tag, okay? So that's like what we call a percent increase. You know, nobody did the Thanksgiving challenge this year. Thanksgiving was a little weird because we were gone and crazy. But, percent gain, like if I gained 10% of my body weight and I was 200, then I would gain 20 pounds, okay? But here's the thing is, if I was calculating that percent increase is a little weird. So I'm not going to say anything more because I don't want to spoil the free problem setness. Okay, so here is, and this is example 5 in the book. So if you want to look at it again, you can. But example 5, here it is. If 75 is increased by 150%. Oh, this isn't very difficult, but hey, you can do it anyway. What is the result? I'll still give you a free problem set. I thought this was another problem. So if 75 is increased by 100, it's not totally easy, by mind you, but let's see if you can get this.
Wait, do we come up and show you?
No, you can show me on here if you want.
Like on the board? Last time I pulled one of those.
Show me on paper. If you don't have paper, then you don't want a free problem set.
I have paper, I just don't have pencil or pen or any writing utensil.
Oh, you know what? I did calculate it and I didn't write it down. So let me
Can I use that pen?
do this again. Okay.
Yeah, don't tell anybody. Get it? Not quite. Okay. I won't tell you if you got it right yet. Confess it. Get it? Okay, keep working. One more minute. See if you can get it in a minute. Get it in a minute. That rhymes.
Kind of. It's like,
It's not a
it
perfect
technically
rhyme. It's like rap
rhymes.
artist rhyme. Which isn't really rhyming most of the time.
Kind of just silly and stuff.
Not really rhyming most of the time. Should I sign with a label? Or? Okay. That's good. I'm glad that you're honest with it. Get it? Get it? Get it?
I got it. Wait.
Yeah, you showed me. What do you have to do?
The reference.
You just say you're halfway there.
Guys, that could have been a hint. Oh, uh-oh.
I got
It's gotta be one of these, right?
Where's the 125%?
Still not sure.
Now, I do remember doing
Oh,
this
look
in
at that.
8th grade or
It's like
7th grade.
Halloween out there.
You don't? You were in this is your first year in math class.
This is their first Flack math.
It's easier.
I used to have teaching textbooks.
Okay,
Teaching textbooks
I'm
is
calling it.
nice.
Did you get final answer? Okay. All right, so, yeah, so these four, you guys, did you get an answer yet?
Who are these four?
That's right. Okay, so this is a two-step problem. And a lot of people stop here. Well, if 75 is increased by 150%, well, 150% of what? 75. So what's 150% of 75? See how I just translated that? 150% of 75 is 1.5 times 75 is 112.5. So that is just the increase. So the result after you increase it, how do you figure out what you end up with? Elian, what do you got?
You just add it into 75.
Yes, step 2, don't forget. Step 2, add it to 75, and you get 187.5. Okay? All right, so remind me before class is done to give you guys 5 more points. Okay? And you.
Oh, it's 5 points.
Yep. All right, so we're going to move on to lesson 48. Whew. This is a long one. That's all right, we'll make it. So lesson 48, we're going to talk about polynomials. What are polynomials? Anyone know? Here's a hint.
It has to
Nathan,
do with geometry.
He raised his hand. But polygons are geometric shapes, yes. But polynomials.
Shaped numbers.
What?
Shaped numbers.
Shaped numbers? Oh, no. That was a good guess, though. What's poly mean?
Polygon
Yeah, like what's a polygon?
shape
With
sides.
how many?
Like
More than one.
Yeah,
Okay.
what she said.
Multiple. Poly means multiple. Okay. And then what about nomials? Nomials actually means, it's another word for name, but in algebra we call the names or the, it's kind of like place value too, but they are terms. So nomials means terms and poly means multiple. Okay. So this is a monomial. What does monomial mean? What's mono mean? One term. So one term. Okay, so that's, and it's not really considered a polynomial. So 4x squared, negative x cubed, comma, not plus, but comma, negative 1.414x to the 32nd. And even like 7 is a monomial. Doesn't even have to have a variable in it. It just has to be one term. So terms are added or subtracted. So if you're not adding or subtracting anything, then it's a monomial. Okay? So Q is a monomial. Elkin is a monomial. Okay? You're not adding anything to Elkin. You're not subtracting anything from Elkin. He's just Elkin. He's a monomial. Okay? So when you have 2 terms, guess what that's called? Anyone, any guesses? Binomial. That's right. Okay? So 2 terms. So like 4x squared plus negative x cubed. That could be a binomial. Anytime you add or subtract something. Comma. Here's another example. X minus 5. That is an example of another binomial. Okay? Guess what 3 terms is called? Trinomial. These are my favorite. And I'll show you why later. But trinomials, we're going to start factoring trinomials, and factoring trinomials is my favorite mathematical concept in the universe. It is. Okay? Are you okay? Drop your calculator?
Yeah.
Did you fall asleep and drop it?
No.
Okay. I didn't think it would because we're talking about trinomials and nobody can fall asleep while we're watching trinomials. Okay. So that could be like x plus y plus z, right? Could be x squared plus 4x plus 4. Okay? Those are trinomials. All right, so every term, each term, these are 3 terms. So terms are always in the form of something being multiplied by a variable. So you have this coefficient, and then a variable, and then an exponent. Okay? No matter what. In a polynomial, each term has a coefficient, a variable, and an exponent. Now, what about 4? Well, there is a variable there. You just can't see it. Because what happens if you say x to the 0? What happens to that x to the 0? It becomes a 1. It cancels out. So 4 times 1 is just 4. So this actually has an x to the 0. Okay? Well, what about this? What about if I just had y? What's the coefficient of y? 1. There's no number in front of it. You said every term has a number in front of it. Well, if you don't see a number in front of it, it's 1. Okay? And then what's the exponent? Well, if you don't see an exponent, it's also 1. Okay? So for example, it can be written like this. So a times x to the n. So every term looks like this. A times x to the n. So for example, 4x squared, a equals 4, n equals 2, right? It doesn't have to be x. It could be any variable. X equals x in this case. All right? So you got a monomial, binomial, trinomial. And then after that, for now, there are names of polynomials with 4 terms and 5 terms, but for now we just call them polynomials because both of these are polynomials, multiple terms. That's what it means. So if you have 4 terms, it's still a polynomial. Okay, now, so polynomials can have more than one variable as well. So you could have can have multiple variables. So you could have like a x to the n, y to the m, z to the l, blah, 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 and so on. You could have as many variables as you want with their own separate exponents. Okay? All right. So this is just a brief overview of what polynomials are. There's some new definitions here. So if you can remember polynomial, binomial, monomial, trinomial. If you remember polynomial, then you don't really need to even write these down, right? Because you can remember monomial, binomial, and polynomial, or trinomial. Okay, so now we're just going to talk about one more thing and then we'll be done. We're going to talk about the degree of a term. So the degree of a term. So remember, a term is like 4x squared, right? Or like x, or like 7, right? Those are all terms. So a degree of a term is basically how many variables are being multiplied, okay? So for example, it's the sum of the exponents of the variables. So if I said this, 4x squared, y to the third, the degree is 5. Because how many variables are being multiplied? 4x, x, y, 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 right? So how many letters are being multiplied? 2 x's and 3 y's. 5 letters are being multiplied, okay? So if I just had 6xym, what is the degree of this term? 3. There's just 3 letters being multiplied, and they all have an exponent of 1 technically, but you can literally see just 3 letters being multiplied. X, Y, M. There's not multiple X's being multiplied, multiple Y's being multiplied, multiple M's. That's it. So this is degree of 3. If you wanted to add the little numbers, you can. Doesn't hurt you. Okay, what about this? Oh, well, let's I think we're good. Are we good? What about this? Let's do one more. 3. What's the degree of this term? So I'm seeing multiple 1s. But how many variables are being multiplied? 0. So degree is 0 because there's no variables being multiplied. Okay? You see the difference? And that's okay. Having a degree of 0 doesn't mean it's anything less, right? It's actually just a constant. It's a constant term. So a constant term has a degree of 0. A constant term is just a number. There's no literal factors in there. Okay, so now the degree, this is the weird one. Degree of a polynomial, you would think, is just add polynomial. Polynomial. The degree of a polynomial is the degree of the highest degree term. So you would think if you had a polynomial, you just add up all the exponents, right? All the terms of the exponents. No, it's not that. So for example, if I had something like this, 3x squared plus xyz plus m. Well, let's find the degree of each term. What's the degree of this term? 2. So I'm going to put parentheses here, 2. What about the degree of this term? 3. Okay. What about this one? 1. That's right. So you would think, okay, the degree is 6, right? 2 plus 3 plus 5. That's how many variables are being multiplied. No. You have to pick the highest degree term. So it's this guy. So the degree of this polynomial degree or degree of polynomial is 3. It's not hard to do this. It's just hard to remember. The rule is kind of weird. The degree of polynomial is 3 because that is the degree of its highest degree term. Okay? Now, usually in standard, you have a standard form of polynomials, but polynomials are usually written in descending order. Descending order meaning the degrees. Okay? So for example, x to the 5th minus 3x to the 4th plus 2x squared minus x plus 5. See how this is, the exponents go down. And it's easy to see this when there's only one variable, right? You just put the one with the biggest exponent first. Okay? So, let's try something. Yeah, there's when you have multiple variables, that's when it gets tricky. But when you have multiple variables and they all have the same degree, just put it in alphabetical order. So if it had like x to the 4th y, like 5x to the 4th y plus 2x to the 3rd y squared minus x squared y cubed plus 5xy to the fourth. And maybe there's a 6x to the fifth here. See how these all have the same term? They all have, or not same term, they all have the same degree. They all have a degree of 5. Here's 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. Okay, but if I were to spell this out, 6xxxxx, 5xxxxy, 2xxxyy. See how that's all in alphabetical order? Because x's come before y's. All right, so if you have the same degree but different variables, make sure it's in alphabetical order. I mean, that's what I would do. It may not ask you to do this, but it will ask you on one of your tests coming up to put terms in descending order of degree. So you need to know how to do that. All right, I did lie, and I feel kind of bad about it, but I thought that was the end of our lesson, but we do have one more. But this is what we have is just now adding polynomials is something that you've already been doing. We just call them polynomials now. You just have to add like terms. You're just combining like terms. Okay, so let's do that. That's the last part of this lesson is adding polynomials. So polynomials are kind of like numbers in normal math. I say normal math. You line up normal numbers by place value, right? So you can't add tens with hundreds or hundreds with ones or whatever. You line them up by place value. So it works the same way with polynomials. Because place value, tens are like terms with other tens. Ones are like terms with other ones. Thousands are like terms with other thousands. So you can only add things that are like terms. So this is something that you've been doing for a while. X cubed plus 3x squared plus 2. Well, first of all, you can't add any of those together, right? Because these are not like terms. They have x's in them and a couple of them, but you can't add them together. So you're adding this plus this. Okay? So now those parentheses don't really matter because everything is being added and there's nothing being multiplied. So parentheses only matter when there's something being multiplied or if it's being subtracted. Well, it's not. So since everything is being added, you can ignore these parentheses. So let's just take those out because they're confusing. So now we're going to add like terms. Do you guys see any like terms? Yeah, what do you see? The 2 and the 4, there's a good one. The constants. So this is a 6, right? What else is a like term? Anything else? Nathan?
3x and 2x
No. I don't see a 3x or a 2x. Yep, so see how these guys are like terms because they are both x to the third terms, okay? So what happens when you add those together? You get 3x cubed, all right? And then this guy is all by its lonesome. So we're going to keep that the same. So here's our answer. 3x cubed plus 3x squared plus 6. Now, when I started this problem, this was a 1, 2, 3, 4, 5. It was a polynomial with 5 terms. But really, it's not because it's not simplified. Simplify means, remember, combine like terms. Once you combine the like terms, now it is a trinomial. Okay? All right, let's try another one. This one, I'm going to step it up a notch. This is a little weird. 3x to the fourth minus 2x squared plus 3, parenthesis, minus another parenthesis, x to the fourth minus 2x to the third plus x squared. Okay. Be careful, because when you're subtracting, you're just subtracting. You're not just subtracting one thing. You're subtracting three different things. What does that mean? Anybody have a simplified answer? Anybody want to answer that didn't get a free problem set? And then I'll give you one if you get it right. Because this is one of the main problems in algebra and algebra 2. My algebra 2 students still get problems like this wrong because it's confusing. What are you actually subtracting? Anyone want to give it a shot? Okay, that's all right. Well, let's identify some like terms. We can do it. We can do this multiple ways. Let's at least identify the like terms. What do we got? 3x to the fourth, right? And we got an x to the fourth over here. And then we've got this guy, an x squared. There's no other x. Oh, there is. There's one over there, right? So far, so good? You guys seeing that? And then a constant. There's no other constant. And then this one is by itself too. There's no other x to the thirds, right? Okay, let's combine them together. What do you get? Somebody have an answer? How many x to the fourths do you end up with? You get 2, okay? So that's the easy one. I mean, no offense. I mean, it's still difficult. Okay, then what comes next? What comes next in descending order? Nathan? Nope. X squareds don't come next. What comes next? X cubes. So how many x cubes do you end up with? This is the tricky one. What? What'd you say? You said 3? Okay. Well, I don't see a 3 anywhere. The only x cubed I see is over here. So how many do you end up with? 2, positive or negative? Think about this and tell me with confidence. Positive or negative? So you're subtracting this parenthesis, and in the parenthesis you're subtracting. So what does it mean when you subtract? Yep, you chicken scratch, you add. When you are subtracting, that means plus positive. So what I would do is this. So when I want to be able to ignore the parentheses because the parentheses are confusing. So basically what parentheses are only powerful if you're multiplying something by the parentheses or if you're subtracting it. Because when you're subtracting it, what's really happening is you're distributing a negative sign. Okay, so if I wanted to chicken scratch, I would go plus, negative, positive, negative. See what I did there? In one motion, plus, and then change all the signs. Changing the operation is the same thing as changing the sign. So subtracting becomes positive. And this is something we already knew because that minus sign was really close to that anyway, so we felt okay about that. But you are subtracting something that's already being subtracted inside of the parenthesis. So let's just ignore the parenthesis totally. So you can ignore a parenthesis if there's nothing being multiplied and it's just being added, okay? So now we can ignore the parenthesis. So now we've got 2x squared, which we already knew, and then that 2x cubed, we're just left with, there's nothing to add or subtract to it, so you're just left with a positive 2x cubed. Okay, and then what comes next after the x cubes? X squared. What do you end up with x squareds? -3, because you have a -2 here, right? And then another -1. So negative or plus negative, it doesn't matter, 3x squared. And then you just have that one constant and you're done, +3. Okay? That's a tough one. Because of that subtraction, it kind of messes everything up. But let's just remove the confusion and get rid of the parenthesis. The only way to get rid of parenthesis is to distribute. The only thing, and what's being distributed is this subtraction or this negative sign. Okay? So that's what we need to distribute. Let's try another one and then we'll be done. Okay? One more and we're done. All right, see if you can do this. All right. Oh, no. Okay, try that. See if you can do that on your paper. Redeem yourself. You could possibly do this in your head. Kind of keep track of those negatives and everything. You could do it in your head. And you will get to the point where you can do it in your head. You don't have to chicken scratch and stuff. But for now, it's probably a little too confusing for you at this point to not try to at least chicken scratch and get rid of it. You have an answer? Okay, hold on to it for a second, and I'll call on you first. Okay, what'd you get?
Oh, we got 3x to the third
Uh-huh.
plus 2x squared.
Okay.
I got x to the third, but I don't know if it's minus for subtraction. And then I got 9.
Okay, so let's do it a different way. Okay, so in your head didn't work, and that's okay. You shouldn't feel bad about that because you're just learning this. Anyone else have a different answer? Audrey?
I got 3x cubed plus x squared plus 6x plus
Okay. Anyone else get anything different? Nathan?
I got 3x cubed plus x squared plus 6 minus 1.
Plus 6x minus
Yeah,
1?
Sorry. Yeah,
Okay.
6x minus 1.
Okay. All right. So I'm going to ask Audrey what she did because she's the only one who did it with paper and she's the only one who got it right. So let's see what you did.
First, I got rid of the parentheses
Okay.
by distributing that.
Okay. So what did you do? Walk me through this.
So I chicken scratch, so I turned that into plus, and then I made x squared negative.
Okay.
And then I made that positive.
Okay.
And I made minus 5 positive.
Okay. And that's it. Now you don't have to worry about really subtraction anymore. Okay. So now you just follow the rules of addition. So now I'm going to combine these guys. Well, there's nothing right there. So we're done there, right? And then now we're combining this guy and this guy. I think most of you got this one right. So 2x squared plus negative x squared. Usually everyone gets that one right because it's 2x squared minus x squared. But this minus does not just apply to that. It applies to everything in the parenthesis. Okay? So 3x cubed plus x squared. And then we've got oops, I'm going to do that so it's not confusing. Then we've got these x's. So now it's a negative x and a positive 7x. Positive and negative subtract. So you get 6x. And then you've got a positive 4 and now a positive 5. Okay, so that's plus 9. Yeah.
I was confused because on the last problem we did, I don't know what
We added the last thing or something?
well, when I chicken scratched in my head, I added and then put a negative sign to sign over the 5.
Okay, yeah. And you can do that, but then when you chicken scratch this, that negative turns back to a positive. So you could chicken scratch inside here first, and then when you chicken scratch that, it's still going to turn it back to positive. So either way, it'll work. This is kind of a shortcut. So if this is confusing to you, don't do it this way. Chicken scratch inside the parentheses first, then you can even chicken scratch inside these parentheses. So now you know you're dealing with a negative x. And then when you make this positive, chicken scratch everything inside. So you'll chicken scratch that twice and that twice. If you do it that way, that's totally fine. But you see how your head is a very dangerous place to do it because there's too many details to keep track of. Yes.
How did you add 2x squared with the negative x squared?
So after I chicken scratched, you ended up with a positive 2 and a negative 1, right? So add those together. 2 plus negative 1 is just positive 1. So good. All right. Questions? Good job, guys. We made it through 2 lessons.
So you could technically write 1x squared.
Yep, you could. It's just not necessary because, like, if you sit down in one chair, you don't have to say one chair. Sit down in a chair. Okay, so you don't need that one. And technically, it's not simplified because remember the general rule for simplifying is write it with as least amount of ink or lead as possible. So a 1x squared is not simplified. It should just be x squared. But it's not wrong. It's just not the simplest way you can write it. Okay? All right. Good job, guys.
Black math, give me some math and I'll give you some flack. Black math.